Thanks very much. It's a pleasure to be here. Thanks, David. I've never worked with Per or for him or taken a class from him, but I've admired him for a long time. And in fact, a number of years ago, I realised that I wanted to become more like him. Many are called and few are chosen, of course. So I had the advantage of being tall and good looking already, unlike my co-author. But we've learned that centimetres aren't everything. And so I decided to invest in some cognition, and I bought a nutrition book, and then I read it, and I discovered a theory that it was theoretically possible to manage your weight through a combination of diet and exercise. And so I applied the theory, and I reduced my BMI from 37 to 26, which is quite an accomplishment. Thank you very much. It feels like an AA meeting again, doesn't it? And so I bought a suit, and of course I got some socks. But I haven't joined the political party. And in that same theme, so Phil Pardey and I work together a lot in agricultural R&D subjects. We haven't worked on nutrition subjects together before, but as an homage to Per, for this occasion, we started working on a paper we'd been talking about, which is as the title says, and really this is a subject that Per pioneered beginning in the early 1970s, if not sooner. The issues we're motivated by have come up a little bit. We spend a lot of our time lamenting the fact that there's a gross underinvestment in agricultural science in the world, and we see compelling evidence of very high benefit cost ratios, 10, 20, 30 to 1. In spite of that evidence, we're seeing a reduction in funding for science in the rich countries, and that's in spite of a slowdown in agricultural productivity growth. And so we wonder whether policymakers don't understand the evidence, whether we've done a bad job of explaining it, or whether we should be using different kind of things. Money metric measures don't mean much to many people. A second problem that's come up a lot today is the double problem about people being undernourished and at the same time overweight. And from our perspective, we think about what we see is a push to take the already too small research budget and divert it to making food healthier, solving public health problems or nutrition problems through this instrument. And a concern for me and Phil in that regard is that going to make our first problem worse? And what's the opportunity cost of taking this money from a purpose we know is highly productive, putting it to another one, and how effective will it be in that other use? There's a picture of a man who people say saved 1 billion lives. It's Norman Borlaug, and is called the father of the Green Revolution, and Penn and Teller and other people have said he saved 1 billion lives. And that's a different notion of a metric of returns to research that we've been trying to think of ways that will be more captivating for policymakers, and measures like that may work better. We don't know what Norman's benefit cost ratio was, but apparently he saved 1 billion lives. We talk about productivity growth a lot, Phil and I. And this is a graph we've never drawn before. This is a graph of an index of cereal yields in the blue line, based at 100 in 1961 when Per started preaching abstinence. And you see the growth was essentially linear with some wiggles around it. And what that means is, of course, that the proportional growth is progressively slowing, and it's about perhaps half what it was at the beginning of the period in the recent period. And you can see that in the decadal growth rates. They're progressively slowing. The dual of that is the index of cereal prices in the bottom, and we can see them trending down, generally apart from that spike in the 70s. But if you look closely and can do optical regression the way I can, you can see that it's actually slowing down. The rate at which that's falling is slowing, and it's pretty flat by the time we get here. And in fact, you look at the graph over here showing the decades, and these it was falling at slower rates and then actually went positive. Okay, so this is before the 1987 price spike that everybody thinks about. We'd had a more serious problem going on for much longer than that. one question we can ask is what's agricultural productivity worth? And we can think about, suppose suppose Norman Borlaug had chosen to be a professional wrestler instead, which was one of his other career options apparently. And one way to think about that is to say, what if we reverted to 1960 productivity? What would that do? And so we construct these estimates using Keith Fugley's TFP numbers, which we just take as read for this purpose. And we've got this index for the world of 225 compared with a base of 100 in 1961. And so we say, what would happen if we went back to 100? What would that do? And we can compute, using this formula down here, the value of doing that is the proportional reduction in productivity from 225 going to 100, multiplied by ag GDP, rather than gross value of production we'd prefer, but we're doing it by the value-added measure. What's that worth? And we can compute that for the world as a whole. There's the ag GDP, and so therefore there is the benefit. In 2005 constant dollars would be worth 1.8 trillion. And we can express that per person in the world. That's $266 each, which for people like me isn't so much, but for some people that's a lot of money. And we can express it as a percentage of GDP, and it's 2.9%. But these numbers include some places with falling productivity. If we leave them out, it's about 4% for the world as a whole. Now we can do this for different groups. So in the high-income countries, do the same. So we've got all the different countries in the world, and we do it for all of them, and we do it for the high-income countries. And the productivity growth is pretty similar, but the benefits as a percentage of GDP are much smaller. And this helps us understand why people in Sacramento or Washington, D.C. don't pay very much attention to Phil and me when we talk about productivity. It's a small scale here. In different parts of the world, so we've got the world classified according to the World Bank's measure of income. And you can see over here, that's where the interesting story, so as we go down the table, this benefits as a share of GDP go up. So when we get down to the lower middle income countries, it's a much more interesting number now, 7 or 8%. In the very low income countries down here, we have, it's lower, and that's because of this phenomenon we've been seeing. The agricultural productivity growth in those countries, mainly in Africa, has been very slow. We can break it down also by region. So the high-income region includes North America, Australasia, and Japan and Europe. And then we have Eastern Europe and former Soviet Union. They had low productivity growth. And so these ones are arranged in this table according to GDP per capita. And so you can see the former Soviet Union countries and Eastern Europe had a very low benefit because of their low productivity growth, and we know why that happened. Then we have down the bottom here, we have Asia and Pacific doing quite well as a share of GDP, and again, Sub-Saharan Africa is the low-income place where it's important money per person, but it's a lower share of GDP than you'd wish because the productivity growth wasn't as large as we would have wished. So we can take those numbers and arrange them on this picture. So this is the size of these bubbles represents the population of the country or the region. These are regions, Asia and Pacific in red, India and China, the big ones, of course. The blue is the high-income countries, and the yellow is Sub-Saharan Africa, purple is Middle East and North Africa, and green is Latin America and Caribbean, and the large one's Brazil. And you can see that these are kind of scattered around without too much clear pattern around that average of around $266 per capita. But then when we express it as a share of GDP in logs, you can see very much a clearly negative relationship there. And the high-income countries, oh dear, I wish I hadn't done that. So the high-income countries down in this quadrant and the poorer countries up there. So this is saying that this agricultural productivity growth is worth a lot of money to the poor. It's a relatively large amount of additional income they would forego or they would receive if we reversed what had actually happened. One way to think about how this works is to draw a graph of per capita income. So I want to remind myself to say these are national aggregate average numbers, of course, and we wish we were talking about actual distributions within countries and so forth, but it's indicative of the story, okay? And so now we're looking at a hypothetical distribution of income, and we can see the poverty line and the people below the poverty line. That's a measure of that. And we say, well, suppose we do some innovation and people adopt new technology and we can shift this distribution to the right. We've reduced the fraction of people in poverty quite a bit. but that's not the most interesting part. We also shift the poverty line back. We make food cheaper. And so we further reduce the total number of poor people in this economy in two ways. And so we get the direct effects, the benefits from adopting the technology. If you're a net seller and you adopt the technology, you're better off. If you're a net seller and don't adopt the technology, you're worse off. But then we have the indirect effects, and we have benefits to consumers. These price falls reduce the benefits to the adopters and non-adopters alike. And then we have indirect effects on employment and so forth through the rest of the economy. And clever people who know more about these things than I do, like Derek Biley and Alain de Janvier and Betty Satterley, have talked about the rising importance of these indirect effects as we go forward. And as we have an increasing share of the poor living in cities rather than on farms and so forth. And so the real question is, when we look forward, where will the poor be found when we're looking forward 20 and 40 years, how long agricultural science takes to take effect? Where will they be? Will they be more interested in trying to adopt this technology as farmers or trying to reap the benefits as consumers of lower food prices? This is a distribution over time of countries arranged according to per capita income. And this is the marginal budget share. So if you get an extra $1 of income, how will you spend it? And the blue part is food, beverages and tobacco, and these other parts are furniture and housing, medical and health in red, furniture and housing and transportation, communication and other. And we can see how this food budget share averages about 30% across all of these countries, but for the low-income countries it's 48.5%, and for the high-income countries it's only 20%. And so when we get this additional income resulting from making food cheaper, this has a big impact on food consumption for the very poor relative to the rich people. At the same time, it can have an effect on spending on health and medical as well. And so this is these marginal budget shares now arranged, and the bubbles are the size of the countries again, and we see this same kind of pattern where Africa's up in the northwest there, and the high-income countries down in the southeast, you can see basically this funny colour pattern where the red and yellow are in the top left and the blue are in the right. And so as we go from the very top, we're up around 60 or 70% of the marginal dollar going on food, and hardly anything go on health and medical, and rich people do something the opposite. And this is additional spending. It's not necessarily additional calories, it might be less calories actually. So it's more money spent on food, and so that can be quality upgrading as well as more quantity. Now this is where Phil and I get into slightly deep water. We step out of our comfort zone and start talking about things that other people here know much more than we do about. But we're trying to get in this area. Can we talk about measures that make more sense or of more interest to people other than us? So here's a graph of life expectancy at birth from 1870 through to today. The top blue one is the high-income countries, and we can see, just looking at them for a minute, they start back here at under 40 years of age, life expectancy, and that just grows up as you go along. And in the early period, so this is from drawing in particular on work by David Cutler and colleagues, who summarised a lot of evidence on mortality, and they say, we believe, because they say, that the first 100 years or so they're talking about up till around here, the big story was the effects of income and nutrition, and then we entered the period where public health became important as well, up until around 1930, and then we got medical influences going on. So we've got all of that going on, but also income and nutrition happening all the way, and we can see we've just arbitrarily chosen 40 years of age. Life expectancy is an interesting number. The high-income countries got there in 1885. The Eastern Europe and former Soviet Union took another 38 years to get there. The Latin American Caribbean took a bit longer, then the Middle East, then Asia and Pacific, and finally Sub-Saharan Africa. So now everybody in the world now is above where the high-income countries were less than 200 years ago. That's interesting. We see what's happening over time, that these patterns actually diverged for a period there, and since then they've been converging, except for these guys. Okay, so there's an interesting pattern there. using those same data in a different kind of way. So this is these bubbles again, the size of the country. So we've got a cluster in 1800 rather, where the average was around 31. And there wasn't that much difference among these countries of the world, according to their income and so forth. And then we're going to jump forward in time 50 years at a time. These are Gapminder data, and see what happens to this thing. And so you see there, the high-income countries jumped ahead. They jumped ahead a bit more, and then everybody jumped up, and then boom, the Asia-Pacific jumped ahead of Africa. And so we've got now we've got a much bigger spread of countries on this scale. It's a log scale, and we can see that this is a type of Preston curve, and we can see there's still a significant relationship between income and life expectancy is one of our measures of what matters. Looking at death caused by nutrition-related diseases, we notice, and we've spent a lot of time trying to learn about this stuff. Phil and I have read more than you could possibly imagine we'd want to try to get up to speed. And we've reduced it to this picture. But this is a picture showing how the people in the high and upper middle income countries, they tend to die of different things than the people over here in the lower middle income countries, especially among the nutrition-related causes of death. Another look at this information is here. We're taking now account of age as well as per capita income. And as we go to the back, we're increasing age. As we go from right to left, we're going from high income to low income. You see, cancer is a disease of rich old people, and down here we have diseases of poor young people, and particularly in the low income countries. And so we get this different stories about the different kinds of nutrition-related causes of death. This horrendograph is here to remind me and you that there's a lot going on. How many is that? You've covered up the number. That's better. So this is what we've been saying. There's the complex links where agricultural science, that's our thing, goes into this pathway and with a lag and gets over there. And so here's this problem for somebody who wants to set public spending priorities. We've got all these things people say might be objectives, like I often say, well, we just want to do the best we can for the economy as a whole. But somebody might be more concerned with incomes of poor farmers and others, or just poor farmers, a particular group of farmers. Or they might care about nutrition, or they might care about obesity. And we've got these different ways we can get at it. And so we might say, well, how should we spend our money? But what about research? How much of this money should go on that? But what kind of research? How much of it on nutrition versus medical research? I'm sure the nutritionists have got an answer for that. And then among the agricultural research, how much should go on down here, this research that has the maximum payoff to society, versus these newer ideas about emphasising micronutrients, or what some people say we should do, fruit and vegetables rather than grains and livestock. And how much should we do on those? And there's a question about matching targets to instruments. In the public economics, we say you should have an instrument that matches the target. And so suppose we wanted to do research to help the poor. So should we focus our money on research oriented to resource-poor farmers in marginal areas? Is that the best way? And so we can fill in this table. We say, does it actually affect that objective? Is it a cost-effective way of doing it? Is it efficient? Does it do more of that compared with one of these other instruments you might have used? And does it do harm to some other purpose? So we have this kind of idea we use sometimes. And so if research was our only instrument available to us, if we spent it all on maximising efficiency, we'd be down here. We have less equity. We say if we spent it all on equity, we'd be up there. But so we go for a compromise in between. We get there. You say, that seems like a reasonable compromise. But I say, no, it's not. We have other instruments available to us. Why don't we combine this with other instruments? Then we've got a new benefit transformation curve. We can have more of both if we use research, what it's good for, and we use other instruments for achieving equity purposes. And that's a straightforward argument, and I think it applies. Now, obesity. I know something about that, not just from personal experience. I've been studying it. And so I've done work with Joanna Parks and Abby Okrent, and we've measured, so whether you should have an obesity policy or not is a question economists can ask, And our answer typically would be, if there's an externality, you can justify policy. And so we're the first people to measure the externality. And so we estimate that obesity adds $166 billion to healthcare costs, public healthcare costs in the United States. Other people have measured things like that, but we've measured the dead weight loss associated with it as well. And we say it's worth about $3 per pound per adult, the excess cost of obesity, compared with if the ideal is 25, a BMI of 25. And so with the same authors who have used this to compute the benefits from a hypothetical change in research spending in the United States. And we've got this complex model that Abby Okrent has, in her dissertation, where we can model the effect of changes in food prices on food consumption, the change in consumption on nutrition, the change in nutrition on obesity, the change in that healthcare costs, the dead weight costs. Okay, we've done all that. And so we do an experiment. We say, suppose we do a 10% increase in research on all commodities. That is going to increase consumption by that many kilocalories. Another thing we can do is cut spending on other commodities by 10%, increase spending on specialty crops by 10%. Barry Popkin wants me to do that. And that would reduce calories by 5.8 per person per day. Or we could just go back to 1980. So go all the way back to 1980. And that would actually have an effect on calories, 85 calories per person per day. The body weight effect of that in the long term would be 1.75 pounds per person per adult if we just cut it 10%, increase 10%, or 11 pounds per adult. Still not enough to solve the problem if we went all the way back to 1980. What's it worth? We take those numbers. What's the effect on public health care costs if we can reduce body weight by 11 pounds each? That's 23.9 billion per year. That's quite a bit. But the change in social welfare is 10 times as big. The loss of consumer surplus associated with that reduction in research, that increase in food prices, is 10 times as big. And so the net story is we're losing money using changes in research to fund increases in prices and save obesity that way. What's it cost? It costs $60 or $80 per pound to reduce obesity using a distorted research policy. So it's a comparatively inefficient instrument, and if you want to reduce obesity using high prices, it's better to leave your research policy alone and just tax calories. All right? Our estimate, if you tax calories, is instead of having a $60 per pound cost per pound loss, you get a $1.77 pound benefit. Now, this is not even allowing for the food industry to respond. If we think that these guys are capitalists, they'll respond, and it'll be even better than that. All right? So we do it for other taxes too. Even a sugar tax would be okay, but that's on all uses of sugar, not just in soft drinks. Okay, so that's the end. Actually, this is where I was going to wrap it up, but I think you got the message, so I'll just call it done and shut it down. Okay, thanks.